Okay, let's recapitulate what dilation is. A dilation, it's a transformation that produces an image that is the same shape as the original, but it is different size. A dilation stretches or shrinks the original figure. So either it enlarges or it reduces the original size. Next here, notation is dk here. This one stands for the dilation, and k here, this indicates the scale factor. It indicates the scale factor. For example, say that D2 is written. That means the original shape is dilated by 2 by 2. It's an example. Next, already in the previous class we discussed the vocabulary, the new terms. A dilation is a transformation that alters the size. Already I told you that altering means the change of size, the change of the size. That alters the size of the geometric figures but does not change its shape. So the shape remains the same. Therefore, it is similarity transformation. An expansion or enlargement enlarges the original figure proportionally. That means each and every part of the given figure enlarges. To create an expansion or enlargement, we should multiply both x coordinate and y coordinate by a number greater than 1. Greater than 1. Next, a contraction or reduction reduces or shrinks the original figure proportionally. To create a reduction, we should multiply both x coordinate and y coordinate by a number between 0 and 1. Most of the time we take fractions like 1 over 2, 1 over 3, 2 over 3, and at times we may take the value between 0 and 1 as 0.25 times or 0.5 times and so on. And next, the center of dilation is the point about which all other points are dilated. As I told you before, in my previous class, I told that center of dilation I can compare with a light bulb. Something like if you keep your hand close to the bulb, then you see a shadow behind your hand, maybe on the floor or maybe on the wall. It's a big giant one. So the light source I can compare with the center of dilation. The scale factor, a scale factor gives you an idea that how many times the given object or the given figure is enlarged or reduced. If it is greater than 1, it is an expansion, and if it is between 0 and 1, it is a contraction. So center of dilation, already we had a discussion about that. A fixed point about which all other points are dilated. Here in this case, O is the center of dilation. Now let's take let's do some problems. So let me move to my favorite whiteboard. Yep, I'm here on the whiteboard. So couple of questions here. Find the coordinates of the vertices of each figure after the given transformation. That is dilation. Dilation of 4.5. Notice that 4.5 is the scale factor. Therefore, each and every point, that is I is given as -1, 0. M is given as -1, 1. B is given 1, 0. Now, I see that the scale factor is 4.5. I see that the scale factor is 4.5. So each and every point is to be multiplied by 4.5. So when I multiply x value and y value with 4.5, then I get that I prime equals to 4.5 times negative 1. So it's 4.5 times 1. Next 4.5 times 0, that gives me 0. Next, coming to m prime, 4.5 times negative 1, that is negative 4.5. 4.5 times 1, that gives me 4.5. Next, b prime values are 4.5 times 1, 4.5, 4.5 times 0, it's 0. So these are the coordinates of another example. So let's take another example. Here, dilation of 0.25. 0.25. So here is the scale factor. Now this time I have to multiply x, g and w values with the 0.25. So x is 2, negative 1, g is 4, comma 4, w is 4, comma negative 1. So let's take 0.25 and multiply each of these values, that is x coordinate and y coordinate both. So we have to multiply both an x and y values. X and y values. Okay, now when I multiply 0.25 times 2, feel free to use your calculator. That gives me 0.5. Then 0.25 times negative 1, it is negative 0.25. As I told you before, use a calculator. 0.25 times 4, it is simply like 4 times 4 quarters. That makes 1. And again 0.25 times 4, it is same as 4 times quarter. So that gives me 1. Then w prime is 4 times 0.25, it is 4 quarters, 1, and negative 1 times 0.25, negative 0.25. Then let's take the next example. This time, this question is almost similar to the previous example, but an extension. First, let's plot all these points. J, negative 1, this is 0. Oops, let me take, pen. This is 0, negative 1, negative 2, 3, 4, 5 on x-axis. On the right side, 1, 2, 3, 4, 5. On y-axis, 1, 2, 3, 4, 5. Below 0, negative 1, 2, 3, 4, and 5. Okay, so let's plot these points. J, negative 1. So on x-axis, negative 1, y-axis, negative 1. That is point J. Then U1, 3 on x-axis. On x-axis, 1 is here and y-axis 3 is here. So this is going to be point U. Next W0 and negative 2 That's going to be this one. Then later on, take a straight edge, join all these 3 points. Now you got a triangle. Now let's write all these 3 points. J, -1, -1, U, 1, 3, and W, 0, -2. And I see that here the scale factor is 1.5. So you have to multiply each of these values with the 1.5. It is same as the previous example in order to get J prime, U prime, and W prime. So let's take and compute 1.5 times -1, 1.5 times -1, that gives me -1.5. 1.5 times -1, once again -1.5. Then when I multiply 1.5 times 1, that gives me again 1.5. 1.5 times 3, you make use of calculator, you get 4.5. Next 1.5 times 0, that gives me 0. 1.5 times -2, use calculator, then you get 3. Now you have to plot these points. So J prime is -1.5. So I'm not sure, just it is somewhere between -1 and -2. Likewise on y-axis too. Therefore, approximately you'll get J prime here. Next, U prime is 1.5. So that falls somewhere between 1 and 2. So on x-axis 1.5, so between 1 and 2, and y value is 4.5. So between 4 and 5, these two are meeting at this point. So this is going to be U prime, and next W prime is 0 and -3. It's easy to identify here on the coordinate plane. Once when you get it, take a straight edge. If you are working on paper, then join all these points to get the dilated figure. So this is the resultant figure. This question is almost similar to the previous one. But in the previous question, you see that the points were given, then we plotted those points on the coordinate plane. Here, the diagram is given, so we have to identify the points. Like, let me mark the numbers on the coordinate plane: 0, 1, 2, 3, 4, 5. These all are in quadrant 1. So I'm not marking the other numbers. So I see that point D is x value is 0 and y value is 2. And when it comes to point L, you see that on x-axis it is on 1 and y it is 5. So it is 1, 5. Coming to point W, x is 5 and y is, you can see that it's 4. So it is 5, 4. Now, the scale factor, you see that it is 1/2. The scale factor is 1/2. So you multiply each of these values with 1/2 to get their primes, or the dilated figure points. So D prime will be half of 0 is 0. Then half of 2 use calculator. Half of 2, you know that it is 1. Next, L prime, half of 1 is half. You can write as 0.5 or maybe 1/2. I personally prefer to write in decimals. Now, half of 5, come on, you think in terms of money, half of $5, that gives you 2.5. I'll say 2.5. Then again, half of 5 and half of 4. As I told you before, all of us love money. Obviously, when we do the calculations in terms of money, that gives you a quick answer. So half of 5, for me, it's easy to compute because I'm thinking in terms of money. Half of $5, that is $2.50 or 2.5. Half of 4, that is 2. Now, let's plot these points on the coordinate plane. First one is d prime 0, 1, x value is 0, y value is 1. This is going to be d prime. L prime is 0.5. So 0.5 lies between 0 and 1 on x-axis, and y is 2.5. So between 2 and 3. So these two are meeting at this point. Let me label it as L prime. W prime is 2.5. So between 2 and 3 and 2. So these two are meeting at this point. This is W prime. Then if you are working on paper, use straight edge to join all these points. And this figure is half of the original triangle. This is half of the original triangle. Let me take one more example of the same kind. Here, there are 4 points. It's a quadrilateral. So point A is, you can see the numbers on the x-axis it is 1 and on y-axis it is 2. So 1, 2. So point A, you can see x-axis is 1 and y-axis is 2. Now let me take point U. Here on the left side on the graph sheet, therefore negative 1, 2, 3. So the value of U, it is x value is negative 3 and y value is 1. Now let's look at point D. It is on the x-axis. X value is negative 3. Obviously, the value of y is 0 because it is on x-axis. You can see that if you mark this way, you can see that it is on 0. Next point J, that is the value of x is, I see that 1, and the value of y, it is negative 3. Now the given scale factor is 3/2. So all these values are to be multiplied by 3/2. 3/2. Then, oops. Okay. So A prime is going to be 3 ones are 3 divided by 2. So 3 divided by 2, I get 1.5. Then 3 times 2, that gives me 6. 6 divided by 2. 6 divided by 2, that gives me 3. You feel free to use calculator. Then U prime is 3 times negative 3. That is negative 9. Negative 9 divided by 2, or half of negative 9. That gives me negative 4.5. Next, 3 times 1, 3 divided by 2, that gives me 1.5. If you have difficulty in computing, use calculator. Now, 3 times negative 3, already we multiplied earlier, that gives me negative 9 over 2, negative 4.5. 3 times 0, 0. 0 divided by 2, that's 0. Next, 3 times 1, 3 ones are 3, divided by 2, that is 1.5. 3 times negative 3, negative 9 over 2, because everywhere there is a denominator 2. So that gives me negative 4.5. Now, let's plot all these points on the coordinate plane. First one is A prime. First one is A prime, which is 1.5. So on x-axis between 1 and 2, and the value of y is 3. So these two are meeting at this point approximately. This is going to be my A prime. Coming to U prime, U prime, it is negative 4.5. So on x-axis, negative 4.5 is here, and y is 1.5. So 1.5 means that lies between 1 and 2. So this is the point where I see U prime. Next, D prime is negative 4.5. So it's already identified. It's on x-axis. So this is going to be D prime, and J prime is 1.5. So between 1 and 2. And this time I'm going downwards because negative 4.5. So negative 4.5 on y-axis, that lies between 4, negative 4, negative 5. This is going to be my J prime. At the end, join all these points, using a straight edge. If you are working on a piece of paper, then we got a dilated quadrilateral, which is a 3 over 2. 3 over 2 means if you convert them into mixed fractions, it is 1 over 2. I hope you know how to do it. 3 over 2, so 3 divided by 2. 2 ones are 2, take away 2, you are left with 1. I prefer this clockwise method. So I start with 1, then the next one is here, it comes to the remainder 1 over 2. So it is 1.5 times. I see that the given quadrilaterally is dilated 1.5 times on the coordinate plane. Okay, let's take another example. Here, the dilation is given, and you are asked to write a rule to describe each transformation. You are asked to write a rule. So here, write a rule means you have to find what is the scale factor. So for computing that, you can take any one point. Uh, Instead of negative numbers, I personally prefer to take positive numbers, that two small numbers. I see that here is 2 and here is 3. It seems these values are pretty easy to take and compute. So let me take these two. So I hope you remember scale factor rule. Scale factor. Think for a while and try to remember what the scale factor rule is. In my previous class, I told you that scale factor you can think as a SIP. So scale factor equals to I stand for image and P is pre-image. So I told you that you may memorize by taking the first letters. Scale factor, first letter is S, image, first letter I, and pre-image, first letter is P. So SIP. So take one of the points from the image. Please remember the final product is the image, and the original one is the pre-image. So I'm taking image means here 3, and pre-image the corresponding value is 2. As simple as that. Therefore, the scale factor is 3 over 2. Let me take one more example. So here you are asked to write a rule. Then let me take a scale factor. Remember SIP. So image over pre-image. Then the first one, the original one, is the pre-image, and the product, that's the image. As I told you before, I prefer to take the positive values, and let's not take, okay, this is positive and this is 4.5. Well, so the formula says that image means here 4.5 over the corresponding pre-image value 3. So make use of calculator, you get 1.5 or else maybe 3 over 2. Therefore, that's the scale factor. So when you're asked to write a rule means technically you're asked to find the scale factor. Next question is the same, but this time you are given a diagram and you are asked to find the scale factor. Unlike the previous question, we don't know these values. So what we have to do is take any one value. Let it be point D, N, P, or M prime. So let me take point D. I see that it is in the first quadrant. I see that this is 0, 1, 2, 3, 4, and this is 1, 2, 3, 4. So point D is x value is 2 and y value is 2. And when it comes to D prime, you can see that on x-axis it is 4, and y-axis this is 4. Okay, so as you know that this is the original one, pre-image. D prime is image. So scale factor equals to, think of SIP, so it is image over pre-image. So image is, you can take any one of the points, let it be x value or y value. So image value is 4 here, pre-image value is 2 here, 4 over 2, that gives you 2. So this is the scale factor. This is one method, and there is another method. If you want, you may find the length of two sides instead of taking the points. Let me write the condition first. Now I'm taking image. Image means the end result here, n prime, p prime I'm taking. So n prime, p prime, that gives me, here I see that 2 blocks, and pre-image, the corresponding NP is 1. So 2 over 1, which is scale factor is 2. You see that you take the points, or you take the length of line segment, still you get the same result. That's it.